Welcome to today's Explainer. We're jumping right in because today's topic is an absolute game changer. We're talking about taking just a bunch of scattered numbers and using math to actually model real-world trends and predict the future. It's like having a crystal ball, but with logic. So let's get ready to completely transform how you look at the data around you.
Okay, here's our quick roadmap for the Explainer. Number 1, the power of data. 2, finding your slope. 3, building the equation. 4, real-world examples. And 5, education and morality. Let's hit the ground running with step 1.
Section 1, the power of data, understanding the story behind the numbers.
You know, it is so easy to look at a scatter plot and just see a totally chaotic mess of dots. But data isn't random. It's literally a story waiting to be told. Every single number represents something real. And I want to anchor this right here with a really beautiful scripture from Proverbs 10:14. It says, wise people store up knowledge. And honestly, that's exactly what we're doing when we gather data. Whether you're tracking your weekly bike miles or watching your savings account grow, you're storing up knowledge about the real world. You are literally practicing wisdom.
But that brings us to a huge question, right? You've been wise. You've gathered all this scattered knowledge. So how do we actually turn those dots into useful, rock-solid predictions about tomorrow or next month? How do we bridge that gap?
Well, the answer is equations. They give us a clear way to understand the story behind all those numbers. Specifically, linear equations. They are basically our ultimate tool. They let us take all that seemingly disconnected information, find the hidden pattern, and make incredibly logical decisions about the future.
Moving right along to section 2, finding your slope, connecting the dots.
Now for the actual mechanics. And hey, don't let the math intimidate you. It is just a series of super simple logical steps. Think of these 4 steps as your master blueprint for any scatter plot. First, choose 2 meaningful points. Second, calculate the slope. Third, find the y-intercept. And fourth, write your final equation as y equals mx plus b. See? It breaks a complex problem down into totally manageable bite-sized pieces.
So let's talk about slope. The definition is simply the change in y divided by the change in x. But here is the pro tip. When you're picking your 2 points, make sure they actually follow the overall trend. You really want to capture the general flow of the data. Just go ahead and completely ignore those weird outliers that are sitting way off in left field.
Okay, section 3, building the equation, putting the pieces together.
So we've nailed down the slope. Now we take that slope to figure out our exact starting line. In math, we call that starting line the y-intercept, and we use the letter b to represent it. It's just this starting value of our model, and finding it is actually super satisfying. Once you have your slope, or m, the y-intercept is just that final missing puzzle piece. You literally just plug your slope and one of your points into y equals mx plus b and solve for b. Boom, done.
Section 4, real-world examples, math in action.
All right, theory is great, but let's see this math actually work in the real world. Imagine we're tracking how far someone bikes. We look at our grid and grab 2 clear data points. At 2 hours, they've gone 10 miles, so that's point 2, 10. At 4 hours, they've hit 20 miles, so point 4, 20. Following step 2 of our blueprint, let's calculate that slope. The change in y is 20 minus 10, which gives us 10. Divide that by the change in x, which is 4 minus 2, leaving us with 2. And 10 divided by 2 gives us a solid, undeniable slope of exactly 5. And here's the magic. Look at how beautifully those 2 raw data points transform into a clean predictive equation. Because our starting point, our y-intercept, was 0, the final equation is just y equals 5x. With this one tiny equation, you can now predict exactly how far this cyclist will go at hour 10, hour 20, or literally whenever. Let's try another one. This time, something that hits a little closer to home, saving money. This is honestly one of the best real-world uses for linear models. Let's say at month 1, we've got $25 saved. That's point 1, 25. By month 3, we're up to $65. Point 3, 65. Okay, let's find the slope. Change in y. 65 minus 25 is 40. Change in x. 3 minus 1 is 2. 40 divided by 2 gives us a slope of 20. Basically, this means we're stashing away exactly $20 every single month. Now for the y-intercept. We plug our slope of 20 and our first point, 1, 25, into the formula. That gives us 25 equals 20 times 1 plus b. A little simple algebra tells us b has to be 5. So, our final equation? Y equals 20x plus 5. In plain English, we started with $5 and we're adding $20 a month. Real quick before we move on, I want to give you a bit of a reality check. When you do this on your own, remember that real-world data is usually pretty messy. These models aren't always going to be a perfect fit for every single point, and that is totally fine. Just avoid the outliers. And guess what? It's completely okay to estimate if a point isn't sitting perfectly on a grid line. That's just the art of modeling. All right, here's a quick look at your homework tasks. You've got 5 things to tackle: writing an equation from points, finding a slope from a graph, calculating a y-intercept, explaining slope in a savings context, and defining why we even model data in the first place. And honestly, I'm absolutely positive you're going to crush it, because you now have the exact master blueprint to solve every single one of these.
Section 5, Education and Morality, the Bigger Picture.
Now, as we wrap up the math side of things, I want to shift our focus just a little bit to the broader implications. In the Smart Academy Godly Learners series, it's absolutely crucial that we understand why we learn. Think about this for a second. What is the point of being incredibly smart and mathematically educated if you just go out into the world and make bad, immoral choices that end up hurting yourself and other people? Academic intelligence is an amazing tool, but man, without a moral compass, it can so easily lead you off course.
And that's the core philosophy behind everything we do here. Education without morality, it just leads to bad choices and hurt. But education combined with biblical morality, now that creates a successful, purposeful life. It literally protects us. You learn the math so you can understand the world, but you hold tightly to your morality so you can navigate it safely. I'm going to leave you with this incredible promise from Romans 8, 6-7. It promises absolute peace of mind to everyone who keeps his or her mind spiritual. We see this happen every single day. When you combine rigorous academic learning with the strong spiritual focus, you don't just get smart, you get genuine peace. So as you go out and model the data of your own life this week, I'll leave you with this. How will you ensure your choices are guided by both wisdom and morality?